Alright guys, welcome back to my YouTube channel, and today we're going to continue the development of SHA-DE. So I apologize, I've actually been off for a while. I had to do some things, but yeah, I'm back, so let's continue. So today, in the last class I talked about how to connect the ESP using Micropython to Wi-Fi, and I showed us how to create the boot.py file. In this particular episode, I'm going to show you how to publish and subscribe messages right from the ESP, right? So that way we can finalize communication between our devices and then move on to other complex parts of the project. So let's get started with that. At this side of my screen, I have the Micropython IDE, which is Tony. And on this side of my screen, I have the Mqtt Explorer, as you guys can see. So I can, in real time, see the messages that I'm actually publishing or subscribing to. All right. So just a quick recap. Already have the boot.py file in this ESP already. So if you go to file here and if you go to open MicroPython device, you'll see there's a boot.py here, which is basically the code that allows the ESP to connect to the Wi-Fi network using the password that we've created so far. So now let's create a main.py file, which is going to be like the one that actually does the actual publishing and subscribing to the Mqtt broker. So what I'm going to do right now is just to copy a code I've already written somewhere before, then explain that code to you guys. It's quite straightforward and easy actually. So let's start from the beginning. I'm importing some things here. I'm importing time, which is going to help us to create delays. I'm importing machine, which basically allows us to control the pins, the GPIO pins of the ESP. I'm importing a particular library called Mqtt sample, and from that library I'm importing the Mqtt client class. I'm going to explain this shortly. I'm also importing a random so I can generate random uniform numbers, and I'm also importing this U binary ASIC module. I'm going to explain all the functions of these modules shortly. Now let's start with this Mqtt simple. Now the truth is that, remember when we were publishing and subscribing to the topics in Mqtt broker from normal regular Python, right? We used a library called POW, but that library does not have a version that is supported on MicroPython, so we have to find an alternative to that. So the alternative is this library called Mqtt simple. Now, one thing about MicroPython is you don't really have that luxury of just pip installing any module you want to install. So basically, this module is actually a file inside this ESP. So what do I mean? Now, if you go to your web browser and then just search for MicroPython and Mqtt, right? Now, the very first link here is a link that leads you to random net tutorial. Now, what this guy did is that he actually created his own library to publish and subscribe to Mqtt broker. So that was the library I actually took and then I'm using. So here he has a link to the library here. So if you open this file here, you can see this is a library here. So what I did was to copy all this, right? Ctrl C. Then you want to go to back to your MicroPython IDE and then create a new file, paste that here, then you can save this file. Ctrl S, you save this file in your MicroPython device. So I already have it saved as Mqtt simple.py here, right? So it's a code, it's a file inside the ESP. So I'm not going to do that all over again, but I've done that already. So now it means that from inside this code, I have all the things needed to perform my Mqtt operations. Now I don't need to go through this code, and really there's no need for you to understand what's inside this code. The main thing that is for you to know is that this code allows you or provides the necessary class used for publishing and subscribing, just like the POW library did for the regular Python. So now let's go back to our main.py. So inside this Mqtt simple, there's a class called Mqtt client, which is basically like the client class for POW. in regular Python. All right, so as usual, we want to define the server where the Mqtt broker is running. We also want to define a name. So I try to call this ESP office. It could be any name, right? But I'm trying to picture a scenario where this ESP is actually in my office, right? So the name of this node in the network is going to be referred to as office. So it's going to be like the base directory for any other thing connected to the ESP. So I'm creating two topics or two variables in this case, right? And the first variable is called topic sub. The second variable is called topic pub. And as the name implies, this variable is going to hold the name of the topic we want to subscribe to, and this variable is going to hold the name of the topic we want to publish to, right? So the name of the variable is name plus slash command. So basically, this is the same thing as saying office slash command. So this is just basically a basic concatenation, right? So I'm saying the name, which is this name here, slash command. And I'm also creating another topic for publishing, right? That is name slash log. So it's going to be office. So what I'm trying to say is that this is the same thing as saying something like this, right? As saying something like this. It's the same thing, right? But I don't want to do it this way. I want to do it. I want to do it this way. So if I ever have to change the name here, it also, reflects on this side of the code. So these are just regular variables holding regular strings, right? The string here is office slash command. The string here is office slash log. Now, just like if you remember clearly, just like when we did the publishing and subscribing from regular Python using the Power library, we have to create a function that is called anytime there's a new message that appears in the topic we are subscribed to. So now that's what this function is doing right here. So I'm creating a function, right? I call that function on message. The function could be any name, right? But this is called on message. So it takes two arguments, topic and message, right? So in the function, the first thing we want to do is to check if the topic that the message was sent to is the name plus command. That is, the topic is the office command, right? Then we want to print ESP received message, and the message has been received. As simple as that. So whenever a message comes into that topic named office slash command, it prints out ESP received message and then prints out the message, right? So let me just put something like a colon here, which will make more sense, right? Now, that's the end of that particular function. So the next thing we want to do is to create a client ID, a unique ID for this particular ESP on the network of devices, right? So we are using this library called being ASIC, right? So this is basically a library that allows us to convert from one should I say data type? No, not one data type. From one so you convert from binary to ASIC, from ASIC to binary with this particular library, right? So for some reason, I just noticed that the client ID has to be an hexadecimal value. If I use any other value aside from hexadecimal, it fails. I guess that is the way this Mqtt library was designed. So that's the reason why I'm using this. And then if you also check that guy's tutorial, this is what he used also. So yeah, so basically what we're trying to do here is just to generate a unique ID using the machine library, and then converting that value to an hexadecimal value, and then using that as a client ID. Simple as that. So and then we are creating the client, the actual client class that does the communication, right? Using the Mqtt class coming from this library we just copied, right? So we are passing the client ID and then also passing the Mqtt server, which is the IP address of the server where the broker is installed. So the next thing we are doing is to set the callback. So we are setting the callback that will be made whenever there's a new message in the broker. So set the callback and then pass in the name of the function that does or that is executed when a message is received. Then the next thing we want to do is to connect the clients to the server. So client.connect. It's very similar to the PAO structure, if you remember clearly. Then finally, we want to clients.subscribe to the topic sub, which is basically the name slash command. right? So I'm subscribing to that topic. And then after that, we want to print something like says connected to the server, subscribe to the topic, blah, blah, blah. All right, so that is for like the setup aspect of the code. And then we have the loop aspect, which is something that is keep repeating as long as the ESP is turned on. So here we are simply saying clients.check message. So this is basically a function that is coming from a method rather that is coming from this Mqtt client class that is provided by this module here. And then what that does is just to check it as a new message. If there's a new message, then it executes whatever it is written in this particular callback function. And now we are generating a random integer between 20.5 and 60.5 using the uniform um, function, right? And then we are converting that integer to a string. And then finally, we are publishing that to the topic bug, which is the name/log. And then we are waiting for 30 seconds before proceeding to the beginning of the loop and then repeating the process all over again. So if I run this code, the expected result should be that every 30 seconds, a random integer value should be published to a topic called name/log, which is the same thing as saying office/log. Now, so let's run this code. I'm pressing this. Now remember that my ESP is already connected to my network, right? Using the boost.py code. So that has to be there by default. And you can see it says successfully connected to this. Now, if you check here now, we have a new directory called office. And under office, we have log. And you can see that every 33 seconds, there's a new value in that log value. I guess that makes sense. So, so the reason why I use this format to create a topic, like the name of the device slash in particular, is so it can be organized in somewhat like a directory format, as you can see here. So I can have multiple values or multiple topics under this office. Now remember that I'm also subscribed to a topic called office/command. So let's confirm that. So what happens is that if I scroll down here and input office/command and then publish a value here, let's say I want to publish a raw value that says ESP32. If I publish this here, you can see that it says ESP received the message BESP32, which basically saying receives a byte that is that says ESP32. So it is, you can also see that that topic was created under this office directory here, right? Because of the office/log and office/command format that I use for the naming of the topic. So it's a very good way using the slash, a character here is a very good way to organize your topics under a particular node. So it means that any device connected to this ESP, I'm going to name the topic that device needs to publish or subscribe to as office/something. So that is how you subscribe and publish values or messages into topics using the Mqtt broker and ESP Micropython. So I believe that makes a lot of sense, right? Now we've successfully subscribed and published through the ESP, through Micropython. Now what I want to do is, I want to organize this code to make more sense, right? And show you how I want to actually do this for SHA-DE, right? In a way that's going to be well organized and well structured. So what I'm going to do is I'm going to copy a different code here and paste here and explain to you guys. Copy. I don't want to copy all this here. Now, it's almost the same code, but it's just slightly different. So I'm importing the same set of modules. The only new value here is this. The only new module here is this JSON module, right? Which I already explained what the JSON module does in the previous class when I talked about the boot.py. Now, and I'm using the pin class from the machine module to create a class that allows me to control the GPIO pin number 2 on this ESP, right? So I can turn on and off the LED connected to pin 2 here. And then just like before, I now have the Mqtt server and also the name of the device, and now there's something new here. So what I did is that I created um, a variable. I created a variable that is called children. So children basically is going to be representing the devices that are connected to this particular ESP. So I'm going to assume that there are two devices connected to this ESP. I have my light, like my main lamp holder in my office, right? And I have a temperature sensor connected to this ESP. That's the assumption, right? So as you can see, light and temperature. So it's a regular dictionary or JSON file with the key values of light and temperature, and then the initial values to be 0 and 0. Of course, this value is going to change as long as time goes on, right? So just like we did in the previous code, I'm creating two new variables, one holding the so this is the same thing as saying office slash command, just like I did in the last class, and this is the same thing as saying office slash log. Just like the previous code, we have a on message function, but this is quite different. So what I'm trying to do now is this. Whatever message that will be sent to this topic called the subscribe topic has to come in a JSON format. I'll show you how that is sent. And then, so whenever it comes here, it has to be loaded as a JSON. So basically, I'm going to receive a command. That command is going to be a JSON of what these children should be set to. So for instance, if I want to set my lights to on or 1, I need to send a JSON that looks like this. But this time around, the value here is going to be 1. You'll see that in action shortly. So basically, the key point is I'm receiving a JSON from the topic, right? And then if there's a light key in the JSON received, right? So if the JSON looks like this, and in that JSON, there's a key value that has light, right? That says light. Then what you want to do is to pick whatever value is in that light, and then if it is a 1, you want to turn on the LED does on, right? Then update the value of this children here. If it is a 0 else, then what you want to do is to turn off the LED and also update the value of lights in this children dictionary to the 0 and ensure you turn off the LED, right? So basically, I'm just receiving a command that says I should either turn on the LED or turn off. Sorry, the lights. When I say lights, I'm also referring to the LED. Yeah, the LED in this case, right? So just yeah. So when I say LED and lights, I'm actually referring to the same thing. Okay, so turn on the LED or turn off the LED depending on the value received. So that is all I'm doing whenever a message is received, right? Then just like the previous code, we have all these things here, right? And the while true, there's a slight difference here, right? So in the while true, what we're trying to do is check the message again. Of course, if there's a new message, then we go ahead and execute this function, right? And we're generating a uniform value for temperature, as you can see here, and then immediately updating that value generated here in the children here, as you can see. So we are updating this value here, and then we are publishing this children dictionary to the topic pub, which is the office slash log. So we are doing two things, right? We are subscribed to the office slash command, which tells us either we should turn on the LED or turn off the LED using a dictionary message, right? And we're also publishing the updated value of the children dictionary or JSON back. So basically, the log topic gives us the updates of whatever value is this light and temperature has been set to, right? And while the command allows us to change those values if you want to. So in this case, we're only changing the lights. Let me run this and you see this in action. So now, as you can see, it says connected to the broker. Now, if you come here, you can see that the temperature is changing, but the light is not changing, right? Because At this point, we are generating a random value for the temperature and then updating that value in the children dictionary, right? And then we are publishing it to the topic pug, which is the log. And of course, I don't have any sleep here, right? That's why it's changing almost instantly. So now, this is it. What we want to do now is we want to send a command to this ESP to turn on this LED connected to switch connected to pin 2. So what I want to do is I want to come to this side of the MCC Explorer, right? Change this to JSON. Then I want to send a JSON that says so LIGHT, and then I'm going to set this to 1. So when we publish this, okay, sorry, I'm publishing to the wrong value. So this is the office / command. Yeah, so we're publishing to this command topic, right? So let's publish this. If that is correctly set, so it keeps changing back. Sorry, oh yes, command, right? So publish. So you can see it says light 1. So that's because I am printing whatever value I receive, right? And then it says turn on LED because 1 was what was received, right? And the LED was turned on. As you can see, the LED is now currently on. So if I change this to light 0, publish, this light goes off. Now, also note that the moment we change the values, right, from 1 to 0 or 0 to 1, you can see that the log also updates, right? So if I click on this, you can see that the log has updated to 1. So they are doing two things here, right? For what I'm trying to do is that for every of my node, for every of my ESP in my house, either in my office, in my bedroom, in my sitting room, they're all going to have 2 topics. One is going to be called command, what is going to be called log. So every device have their command. So every node or every ESP in the network has their command and topic, command and log topic rather. So for the log, it is where they log in values like temperatures, right? Values like depending on what if in my sitting room I have like let's say smoke sensor, right? So that value is going to be updated in the log topic. And if let's say I want to change the fan state or the fan level or my lights states, I'm going to change that through the command topic. So always note that whatever value you are sending, because of we are using a JSON here, whatever value is being sent to the topic has to be a JSON file. That is why I have it in this structure, in this manner. So this is basically going to be the code that goes to almost all the ESPs. All I need to do is just to add more children if I need to add more devices to the ESP and also change the name of the device. So if I have another ESP, let's say in my sitting room, this is going to change to something like sitting room, right? So, and let's say I want to have my lights connected to the ESP, a smoke sensor, I'm going to have like a smoke sensor here. Something like that, right? So let's run this and see what happens. If I run this, you can see that immediately a new directory has been created called sitting room, as you can see here. And then you can see you have the light, smoke, and temperature. So, but the same thing, right? If I decide to publish sitting room command, sorry, CMMAND, and then I'm sending light 1 to this light is going to turn on just like before. And you can see that it says that I sent a command 1 and then light has been updated to 1. So this is what every code on all my ESPs, wherever they are, the bedroom system is going to look like. The only difference is going to be the children and the name of the device, right? Of course, I also have to update this on message. So for instance, if I have a door, my door lock connected to this particular node, I have to also ensure that I'm also capturing that change here and reflecting that change to my door. For instance, now let's say I can just copy this whole thing here, Control C, and then paste it here and change this to door or something. Right. So now I have a door value I can change this to door also. So this will basically like unlock and lock my door. However, let's just keep it simple for now. So remember, all these codes and the GitHub repository, you can go to the description section, copy the code, and then try it out yourself. So I'm going to stop here for now. And in the next class, we're going to talk about the microservices we want to create. So if we come back to this guy here, then going back to architecture, what we've just done is the code that's going to live inside each of this node here, right? So the next thing we want to do is to create this SHA-DE shell microservice that gives us like a central interface to control these devices, because of course we're not planning to control the devices via this MPC Explorer. No, we want to control it via voice command and other nice interfaces. This is just for illustration purpose, but if it works fine in the Mqtt Explorer, it's going to work fine from any other place. So eventually, we're going to have Python codes running on a server that actually does the publishing and then reading of this value that has been subscribed, or sorry, that has been published to the Mqtt Explorer. So let's stop here for now. In the next class, we're going to build our SHA-DE shell here, and then we're going to proceed to building things like the voice control service, the web UI service, and other services. Thank you very much. If you're not subscribed yet, please subscribe, like, and then share. I'll see you later. Thank you.